And today we are going to continue from that point onwards, right? So if I recap the things, we talk about the number systems, like 3 different number systems we get to know, right? Which is the binary, octal, and hexadecimal. And then we talk about the LSD and MSD, right? Now, before we continue to the conversions in between the number systems, I have to mention you about the binary number system specifically. Uh, there is a special a term, or the most significant digit and the least significant digit in the binary number system has given a specific name or a special name as most significant bit and the least significant bit. They use the word bit, B-I-T. It is because the 1 and the 0 is used to represent the bits inside the computer, right? So with that meaning, what they are doing is they are just indicating, or they are just addressing the most significant digit as most significant bit in the binary number system, and least significant digit as least significant bit in the binary number system, right? So the rules are same. The way that you are going to find the MSB and the LSB is same, right? Only the name is the change, right? So let's write that down as the last point of this particular topic, right? Then we can go for the conversions, right? So I'll write it down here. You can copy it. So start writing with me, right? Yes, Dihan, star mark එකක් දාලා ලියාගත්තට ගැටලුවක් නැහැ. Yes, Susu. Oh. Come on. දවසම ගත්තේ නෑ ඕක.
So what would we have to write?
What I am writing on the screen, Buddha, in black color, right?
Yes,
Right. So people, you can copy this down. Let me know when you are done, right? Okay, one is done already. How about the others? Okay, seems everyone is done. So let's move to the big part.
Where?
Yeah, is there anyone still writing this?
Yes, sir.
Right, okay, get it done quickly.
Finish, sir.
Right, okay. All right, so now we are going to discuss about the conversions in between the number system. Now that is the major part of this lesson, right? And we are going to learn 4 different types of conversions, right? So when I'm teaching those things, your book may illustrate it as like actually it's like 10 different conversions, right? But I'm going to teach you those things as 4 different conversions because actually there are only 4 different conversions, right? So I want you to learn the technique when I'm teaching you the things, right? So when you know the technique, it's a piece of cake of doing this particular conversions with me, right? So here we go. So write the topic saying conversions in between number systems. Right? And I'll illustrate what are the number system conversions that we have to do in a diagram format, right? So there are numbers in decimal which we are going to convert into a binary, into an octal, and into a hexadecimal, right? Now, the numbers are given in decimal, so we are going to convert them into the non-decimal number systems. In our case, it's going to be the binary, octal, and hexadecimal. And when you know the technique, it's a easy thing for you to convert the decimal values into any number system, right? When you know the technique, it's not only the binary, octal, and hexadecimal that you can do. You can convert it to any number system you want when you know the technique, right? Now in your textbook, they are giving 3 topics regarding this, like converting decimal into binary, converting decimal into octal, converting decimal into hexadecimal. I'm not going to do that. I'm just going to tell you what's the technique behind it, right? So that is a one particular conversion. And the next particular one is the reverse of this, actually. The non-decimal numbers will be converted into the decimal numbers, right? So the reverse process of this, actually not rather the reverse one, but a different technique, but again, it goes the other way around, right? And the third conversion is about a binary converting into an octal into an hexadecimal, right? And the last conversion is again the opposite of this. Octal and hexadecimal will be converted into a binary. Right now, these are the 4 different types of conversions that we need to go through, right? So this is number 1, this is the second, this is the third conversion, and this is the fourth, right? Copy this down, people. Let me know when you are done, people. Right. Okay, so we are going to do the very first conversion, right? So let's write the very first conversion like this. Right, converting a decimal value into its non-decimal equivalent. Right, give it just a second, I need to...
So we have to write it.
Yes, write it down. Pradhan. So I'm going to show you how to do the calculation, right? Right, so this is the way we are going to do this. Now, hear me out very carefully. So this is a technique. What is the technique? So I'll write you an example. So your example number 1 is going to be I'm giving you a question, so I will do the question. So the question is, convert hold on people 76 a decimal value into its binary equivalent, right? So our task is converting a decimal value, which is the 76. You have to write the base always and into its binary equivalent, which means what is the value in the second base, right? So how we are going to do this? Now the technique is, if you are asked to convert a decimal value into a non-decimal value. So first of all, you have to realize what kind of a conversion is given to you. Here you are given a decimal value to be converted into a non-decimal value. So the first thing that you are going to do is you take the decimal value, which is 76, and you are going to divide it by 2. So the rationale of having 2 is because we are asked to convert this decimal value into a binary. So binary convert කරන්න කිව්වොත් binary වල base එක 2නේ. So we are dividing the decimal value by 2. Right? So when the 76 is divided by 2, what is going to be the answer? There are 3 for 7, so 6 and 1 is remaining. For 16, there are 8. So 38, and specifically and very importantly, we have to put a dash and we have to write how many remainings are there after the division. So that is the technique. You take the decimal value, you divide it by the base that you are asked to convert, then you write the answer, put a dash, and you write how many remainings are there. It doesn't matter whether it is a 0 or a 1, you have to write it, right? You can't omit by thinking there is no remainings, right? If it is 0, you have to write the 0. If it is 1, then of course you have to write the 1. And we are not going to stop just by doing a 1 division. There is an ending point for the division. The ending point can be recognized when you receive a value which is less than 2 after the division, right? There are 2 techniques actually. I'm telling you one particular technique. You have to divide until you are receiving a value which is less than 2 as the answer of the division. Or else you can divide it until you have 0 as your answer. Then you can compose the binary value, right? So here I'm going to do it. I'm going to follow the first technique. So I have received 38 as the answer of the first division. So it is not less than 2. So I'm going to divide it by 2. So 3, there is 1 2's and 1 is remaining 18. For 18, there will be 9 2's. So again, 0 is the remaining part. So 19 is not less than 2. So I'm going to divide it again by 2. This time it's going to be 9. and I'm having 1 as the remaining because 2 into 9 is 18. So once 19 is divided by 2, 9 and 1 is remaining. And still it is not less than 2, so I'm going to divide it by 2 again. So this time it's going to be 4 and 1 is remaining because 2 into 4 is 8. And then I'm going to do the division again by 2 because 4 is not something less than 2. So I'm receiving 2 and 0 remaining. Still, the answer 2 is not less than 2. It is equals. So that means I have to do the division again, right? So I'm doing the division again. So I'm receiving 1 and 0 is remaining. Now, people, I can stop the division or the dividing process. Then I have to start from the place that I stopped and should consider the remainders along from bottom to top. Start from the place that I stopped the division or like the final answer that I got. Then continue the remainders from top to bottom. That gives me the answer by writing these numbers in particular order from your left to your right. So that means the relevant answer is going to be 1, 0, 0, 1, 1, 0, 0 in binary. People, did you got this? Let me have the confirmation. Right, okay. How about others? Right, good. All right. And I told you there is another way of doing this, like dividing the things until you receive 0 as the answer. Right? I'm just erasing this for a moment. I can show the division in here as well. So if you divide this 1 by 2 again, so you will be receiving 0 as the answer and can say 1 is remaining. So then you can consider the remainders only. That is again from from bottom to top, which gives you the same answer, right? So the relevant answer is going to be 1, 0, 0, 1, 1, 0, 0, right? So I'm going to write the answer right over here. So the answer is going to be 1, 0, 0, 1, 1, 0, 0. You can use either of the ways, right? Which satisfy, like which feels you easy, right? Or which makes you easy, right? Okay, people, so write this down. Oh, I'm sorry. There you go. Let me know when you are done, people. Okay, one is done. How about others? All right. Is there anyone still writing this? Otherwise, we can go to the second example. Right. Is there anyone still writing this? Please indicate. All right. So we are going to the example number 2. Now, people, you have learned the technique here. What is the technique? When a decimal is converted into a non-decimal one, you have to consider the base of the value that you are going to be converted, right? And then that base will be taken to divide the decimal value, and you do the division until you receive something less than the dividing number, right? So the second example is about the decimal to octal conversion. So I'm taking the same value, which is 76. We took 76, right? Yes. So this is example number 2. Convert into its octal equivalent, right? I think you have the plan now. So what we are going to do is we are going to convert the 76, the decimal value, and we are going to have the octal equivalent. So what we are going to do is we take the 76 and we divide it by 8. What is the reason for dividing by 8? Because we are converting this decimal value into an octal number. So how many 8s are there for the 76? There are 9, right? I'm sorry. Yes, there are 9, right? And how many is remaining? The technique goes the very same way. So 9 into 8 is 72 and 4 is remaining. Are we done with division? Not yet, because the answer is 9, which is not less than 8. So we divide it by 8 again, because we have to divide until we receive something less than 8 as the answer. So here we are receiving something less than 8, which means 1, and 1 is remaining. So now we received something less than 8. So we can stop the division or the dividing process, and we can consider the answer by considering the last answer and the remainders from bottom to top, right? So we are taking 114 as our final answer, right? So 114 in octal will be the final answer. And if we continue to the second technique, we are going to divide this by 8 again. So we will be receiving 0 and 1 is remaining. So again, we can find what? The remainders from bottom to top. which gives you the very same answer as 114. People, did you got this? Please confirm. Right, great. Please copy this down. All right, someone is instantly done. How about others? All right. Is there anyone still writing this?
Yeah.
Okay, keep writing. Okay, are we
Yes, sir.
done? Right, okay. So is there anyone still writing this? Okay, let's continue. So here we goes for the third example. Now you know what to be converted. We are going to convert the 76, the decimal value, into its hexadecimal equivalent, which is in 16 base, right? So third example. Right, convert the 76 in decimal into its hexadecimal equivalent. So we know the drill. What we are asked to do is convert the 76 in decimal. I'm sorry. Into the hexadecimals. Right, so we know the drill. 76 is taken. We are dividing this by 16. What is the reason? It is because we are converting the 76, the decimal value, into the hexadecimal. So the base is 16. So we take 16. So for 76, how many 16s are there? There are 4, right? 16 plus 16 is 32. 32 plus 32 is 64. That means there are 4 16s are there. And we are left with how many? 12. Right? So 64, 74, and 76, it's 12. But you know, in hexadecimal, we can't write 12 as a symbol or as a character. So instead of 12, we are going to write what? The letter C. Because we know in hexadecimal, 10 is represented as capital A, 11 is represented as capital B, and 12 is represented as capital C, right? And we have find an answer which is less than 16. So we stop the dividing process because we received something less than 16. So we start from the place we have stopped and we write with the remainders from bottom to top, right? Let me adjust the arrow a little bit so I can go with the second way as well, right? So your answer is going to be what? 4C in hexadecimal. If you are going to continue as the second method, so you are dividing this 4 by 16, so you will get 0 and 4 is remaining. So then you can consider the remainders from bottom to top, which gives you the same answer, right? Yeah, that's great. All right, please copy this down, people. So at the bottom of the page, I'm going to write you some questions, right? So you can try those after you copy this down. Okay, someone has done already. So here comes the questions. Convert the followings into their binary, octal, and hexadecimal equivalents, right? So you have to convert a particular decimal value into all three number systems, right? To binary, to octal, and to hexadecimal. And I need the answers through the chat. You can type it in through this chat, right? So the first value is 37 in decimal, and the second value is 155 in decimal. So convert. I need all three answers. Like for 37, what is the binary equivalent, what is the octal, and what is the hexadecimal, right? So do the calculations, people, and we'll see who gets through first. Okay, we got an answer. Yes, Litira, that is correct. Very well done. Go for the second one. And Tedara, the first answer is correct, Dua. Yes, Rusira, first answer is correct. Dilni, first answer is correct. Dilni, the second one is also correct. Risara, yes, first answer is correct, Puta. Very good. And Dilmi, yes, the first answer is correct. Ranuja and Hasita, both are correct. Ranima and Binadi, both of you got the correct answer. Very well done. And Dilni, the hexadecimal answer is also correct. Ranuja, I think you have to work again the octal one. You got a slight mistake, Puta. Dilni, your answer is correct regarding the hexa. Pramod, Puta, there is a problem with the first calculation. And Risara, yeah, binary calculation is correct. Gavindu, I think you have to think about the answers again, Puta. Poddaka I go through kala balana podi mistakes wagak තියෙන answers තුනේම. Rusira, octal calculation is correct. VNet, yes, and hold on, Puta. The first one is correct, Vinet, the binary conversion, but not the octal and the hexadecimal. I think you haven't considered the final answer, Puta. Remainder එක විතරයි ඒකේ පාවිච්චි කරලා තියෙන්නේ. And Tedara, yes, your octal conversion is correct. Anjana, binary, Puta, there is a problem with the binary conversion. Go through that again. Octal is correct. And Litira, yes, perfect. The second answer, that is correct, totally correct. And Rusira, yes, that is correct as the hexadecimal value. Tedara, the hexadecimal value is correct. And Dilni, yes, that is the correct answer for the hexadecimal one of the second. Risara, octal conversion is correct. Dilmi, octal and hexadecimal conversions are correct. Hasita, octal conversion is correct. Very well done. Not yet, Suzu.
Oh, please.
Come on, that is doing the class name. And I'll give it to you after a little while. Huh?
Please.
Taruk, your binary conversion is correct. Risara, hexadecimal conversion is correct. Pramod, binary conversion correct. Pramod, there is a problem with the binary conversion, Puta. Please go through again. What do you mistake at Ranuja, yeah, octal and hexadecimal conversion is correct. Anjana, yes, hexadecimal conversions are correct. Ranima, Dua, this is regarding which? The third one. Tungveni ekke Ranima eka podi, I think there is some mistakes, Dua. Just go through again. Hasita, yes, that is correct answer for the third conversion. Ranima, yes, that is the answer. That is the answer, Buddha. And Rusira, yeah, that is the correct answer for the second binary. Pramod, yeah, that's the correct answer, Buddha, for the first one. And Dilni, that is correct as the octal. And Risara, that is correct as well. Dihan, that's going to be, there are some mistakes, Buddha. Just go through. I think, එක 0 එකක් මිස් වෙලා තියෙනවා. Tedhara, yeah, Tedhara, another slight mistake, Dua. Just go through it again. Antima calculation එකනේ අන්තිම division එකේ මොකක් හරි අවුල් වෙලා තියෙනවා. Okay, so let me do the first question for you, right? So you people can see what has went wrong, right? Meanwhile, you can send me the answers for the second one. Rusira, octal conversion is correct. Hasita, yeah, binary conversion is correct. Risara, hexadecimal is correct. Taruk, octal is correct. Keep it up, people. You are doing good. So here I'm doing the conversions, people. So 37. Tedhara, yeah, that's the correct answer, Dua. Right, so I'm dividing this by 2, so it will be 1 and 8, and 1 is remaining. And I'm dividing by 2 again, so 9 and 0 is remaining. And I'm dividing it by 2, 4 and 1 is remaining. And again, I'm going to divide it by 2, 2 and 0 is remaining. Right, and Dilni, Ranuja, your conversion is correct. Dilni, I think there is some mistake with the hexadecimal conversion. Methul, yeah, that's the correct one though. That's the correct one. And Rosira, that is correct. That is correct. Rannima, yeah, that's the correct answer. Methula, that's the correct answer, Buddha. Tedara, yes, that's the correct answer as well. Yes, Risara, only 6 answers. Methula, yes, that's the correct answer for the third one. Ranuja, yes, that is correct. Binadi, just go through the octal conversion, Dua. I think there is a problem. And Dilmi, that is correct. Yes, Risara. And Dilni, that is correct as well. Hasita, conversion is correct. And Tedhara, this is regarding what? Dua, hexadecimal wala balanna, ekane duවට ඇවිල්ලා තියෙන answer එක වැරදි, and again your representation regarding the value which after the 9 is also wrong, right? Pොඩක් ආයි go through කරන්න. Right, so I'm continuing the calculation. So 1 and 0 is remaining, right? So my answer is going to be, I'm going to start from here and moving towards here. Yeah, the answers are pouring on my chat box. And I'm really happy that you are sending these things. Gavindu, your answers are correct, Buddha. All 3 answers. Ranuja, hexadecimal conversion, there is a problem. Hasita, your one is correct. Pramod, yeah, hexadecimal is correct. Rannima, octal is correct. Tedhara, we don't represent 11 as 11 doer. How we are going to represent 11 in hexa? That is what is missing. Yeah, now that's the correct answer though. That's right. So Anjana, yes. Anjana, there is a problem in your hexadecimal conversion. It's not going to be A, Buddha. It's going to be B. Just see where it went wrong. Other 2 are correct, Buddha. Other 2 are correct. So the answer for the first one is going to be, is this. So I think most of you have take it. Binadi, yeah, that's correct, Dua. That's correct. Right, and for the octal conversion over here, I'm going to divide it by 8. So 4 and 5 is remaining. So we are going to consider like this. So it's going to be 45 in octal. And for the hexadecimal, I'm going to divide 37 by 16. Right, so it will be 2 and 5 is remaining. So it is going to be like this. So the answer is going to be 25 in hexadecimal. Right. So in case if you got anything wrong, just go through and see where it went wrong. Right. And be very careful, people, when you are doing these things, because since you know how to divide, you will feel it is easy. And that will lead you to the mistakes as well. Right. So be careful when you are doing those. Right. Yeah, Pramod, that's a correct answer. Ranuja, that's a correct answer as well. Right, and I am illustrating you the second one, which is the 155. So 155 divided by 2. So this is going to be 77 and 1 is remaining. Right. And this is going to divide by 2 again, and it's going to be 38 and 1 is remaining. I'm going to divide by 38 again by 2, and it gives me 19. 0 is the remaining part. I'm going to divide this by 2 again. 9, 1 is remaining. And here I'm dividing by 2 again. 4, 1 is remaining. And I'm going to divide it by 2 again. 2, 0 is remaining. And I'm going to divide it by 2 again. 1, 0 is remaining. Right. So your final answer is going to be, starting from here, going to the top. Right. So it's going to be Pramod. Yes, yes. Those are correct, Huda. Those are correct. 1001111 is going to be the answer for this. Right. So Ranima, is it 9A? Go through it do again. Binadi, that's correct. So here I'm going to do the octal conversion. 155 going to divide by 8. Right. So 1, 7 is remaining for 75. There are 9 and 3 is remaining. Right. And 19 can be divided by 8 again. So it's 2 and 3 is remaining. So I can stop from there, the division, starting from the place where I have stopped, and I can continue to the top. Right, so it's going to be 233 in octal. Pramod, yeah, that's correct. That's correct. And here I'm doing the very last conversion, 155 in 16. So this is 9. And how many is remaining? 11 is remaining. So 11 means B, right? So you can write 9B as the final answer. So 9B in hexadecimal as the final answer. So people, please go through if you got something in an incorrect manner, so you can make the corrections. But I'll give you 1 minute to go through the things, right? Then I'm going to do the next conversion method, right? And I think I feel that you are very much confident with this, right? So if you got any doubts, you can ask. Okay. Oh, Ranima. Yeah. Yeah, Ranuja, simple B will be okay, but it's better you like go with the capital letters, right? Moකද අපිට සාමාන්‍යයෙන් introduce වෙන්නේ පුතා, it's from the capital, right? It doesn't matter that you write it in simple, use that, but it's better you go with the capitals. Ranima, 455 there are 9 16s. Now 16 into 10 means 116, eh? So this is like 5 less than 160, right? So that means there are 9 16s, and when we take 16 into 9, it's going to give you 144, right? So 144, when you reduce 144 from 155, 11 is remaining. So we are not going to write the 11 because we can't write 11 in hexadecimal. For 10, we use capital A, and for 11, we use capital B. So that is why I took 9 and the B. Is that clear, Anima? Right, great. Okay, so let's move to the next conversion, right? I hope you are done with these things. And if anyone still writing or copying something from this, just let me know, right? Otherwise, we can run to the next conversion. Okay, so let's move to the next conversion. Our next conversion is converting the non-decimals into the decimal equivalents. Right, so that is going to be our second conversion method. Converting non-decimals into their decimal equivalent, right? So now, according to our syllabus, we are going to convert the binaries into decimal, the octal into decimal, and the hexadecimals into decimal, the opposite of the previous, right? So here comes the first example. So the first example, it says convert 1011, this is a binary value, into its decimal equivalent. Right? So hear me out, people. Now, as we learn a particular technique to the previous conversion, this particular conversion has the same technique, right? If you know how to convert a binary into a decimal, and then you know how to convert an octal into decimal, as well as hexadecimals into decimal, right? So here we go. So the first thing that we are going to do is, when we ask to convert a particular non-decimal value into a decimal, it's better we write the number that we ask to convert. And we are going to consider the place values of the characters which is on the given value. So since it is a binary value, and you can remember the abacus that we discussed, right? Now, instead of saying ones, tens, hundreds, thousands, we refer those with the 10 to the powers. So like when we think about the abacus, we discussed this is 10 to the power 0, this is 10 to the power 1, and this is 10 to the power 2, and this is 10 to the power 3 likewise. That is why you call them in your childhood, right, in grade 1 or 2s, like ones, tens, hundreds, and thousands likewise, right? So these are being indicated as 10 to the powers because we are referring to decimal values in the abacus. Now here we are referring to the binary values. So accordingly, we are going to have 2 to the powers. So this is going to be 2 to the power 0. This is going to be 2 to the power 1. This is going to be 2 to the power 2. And this is going to be 2 to the power 3. Right? And people, what will be the place values if this is an octal? The logic is simple. It's going to be 8 to the powers, right? 8 to the power 0, 8 to the power 1, 8 to the power 2, so and so. If it is hexadecimal 1, then 16 to the power 0s, 16 to the power 1s, 16 to the power 2s, likewise, right? So it's easy. And when you are having these place values from 2 to the powers, it's better you convert those into their actual values. Like 2 to the power 0 means 1, 2 to the power 1 means 2, 2 to the power 2 means 4, 2 to the power 3 means 8. Now we have something special to do. We have to consider the place value and the corresponding symbol value. So by considering these two, we are going to multiply with each other. Right? So we are going to do it for each and every place values. Right? So that means we have to create 8 into 1, 4 into 0, 2 into 1, 1 into 1. And then we have to add these things together, which gives you 8 into 1 means 8, plus 4 into 0 is 0, plus 2 into 1 is 2, plus 1 into 1 is 1. So your answer is going to be 11, right? This is from decimals. People, is that clear?
Yes.
Right, great. How about others? So please copy it down. And if you got anything not
Can't see the heading.
Yeah, yes, the major heading can't see, right? Okay. So write down the headings. I'll scroll up the screen, right? And you can continue. Okay, Rusira. So one is done with copying and 2 are done with copying. So please go on. I'll give some time for the others. So this is the second conversion. Okay, 3 are done. All right, I'm scrolling the screen. All right, I'm scrolling it a bit up. All right, meanwhile, I'll write the second example. Right, are we done with this? Can we go for the next conversion? Is there anyone still writing this? Okay, so let's move. So now you know the drill, right? So the octal number is given, asked to convert into the decimal equivalents. So what we have to do is we have to take the octal value, 547. Then we are going to consider the place values. So now it's going to be 8 to the powers. Why? Because we are given an octal number, right? So it's 8 to the powers to its place values. So this means 8 to the power 0 indicates 1, 8 to the power 1 indicates 8, and 8 to the power 2 indicates 64. So same going to happen. You are going to consider the place value, you are going to consider the symbol value, and you are going to multiply, right? So how it's going to be? 64 into 5 plus 8 into 4 plus 1 into 7, which is going to give you 64 into 5 is going to give you 320. 8 into 4 is going to give you 32. 1 into 7 is going to give you 7. So totally it's going to give you 359 in decimal. Am I correct? 20, 32, 52. Yes, 359 in decimal. Right? Yeah, copy this down, people. So I'll write the hexadecimal conversion at the bottom. Yes, as usual, Rusira is done. So I'm writing the third example at the down. You can copy it. Okay, so many has done. Okay, is there anyone still writing down the octal conversion? Litira, yes, base 10 is important, Puta, because, okay, Dihan, keep writing. Because when we are like referring to different kinds of bases, Puta, it's better you mention the base, even it is in the decimal. Right, Dehan, let me know when you are done. Right. So is there anyone still writing this? All right. So let's get to work. So you know the drill, right? I think you can write it by your own, but I'll write it. Right, so it's A58 that we need to convert, right? That is in hexadecimal. So we consider the place values. So it's going to be 16 to the power 0, 16 to the power 1, and 16 to the power 2. So which is going to go as 1, as 16, as 256, right? Now, when it comes to the 16 hexadecimal values, it won't go like more beyond 3 digits for your level, right? So just remember 16 to the power 16, the square of the 16 is 256, right? Right, someone has given me the answer. Let's see whether it is okay. Right, good, good. Right, so the same happens. 256 is going to multiply by what? Not by A, but the value which is represented by A. A represent 10, right? So you are going to multiply 256 by 10. Right, so multiplication happens. So it's going to be 256 into 10 plus 16 into 5 plus 1 into 8. So 2560 plus 80 plus 8. So it's going to give you 2648. 2648 in decimal. Right? So people, yes, copy it down. Oh, it's Delhi, it's 2648 dua. Right? So copy it down. Meanwhile, I'll write you some questions to have the answers. Right? And before that, people, please tell me, is this clear to you all? Is there any problems? Right, brilliant. Let's do some questions. Right, so the question time. Here comes the question. Convert the following values into their decimal equivalent. Right. So here goes the things. Number one, this is in binary. Number two, that is in octal. Number four, I'm sorry, my bad. I should know there's 3 after 2 maybe. This is going to be C2D hexadecimal. Right? Send me the answers, people.
How long does your sex last?
Tadara, first one is correct. Litira, first one is correct. Binadi, first one is correct. Oh, yes. Litira, first one is correct. Binadi, correct. Rusira, correct. Risara, there is a slight mistake. Go through again. Dilni, correct. Ranima, correct. Litira, yes, I think there is a slight mistake regarding the, yes, Litira. Yeah, that's the correct answer. Tedara, yes, that's the correct answer. And Pramod, yes, that is correct. Rusira, that's correct. Anjana, that is correct as well. Risara, yes, that's the correct answer, Puta. Yes, Binadi, that's the correct answer. Dilni, yes, that is the correct answer. Well done. Ranima, yes, brilliant. Ranuja, there is a problem. Go through again. Vinet, again, Vinet, there is a problem. Bana poddak ekatu karanකොට awula Kedara, brilliant. That's the correct answer for the third one. Litira, you have to go through again, Puta. I think you have missed it. The hexadecimal into decimal. Kedara, that's correct. Yes. Metumli, yes, that is correct. Vinet, Puta, it's not that. Vinet, kalabal natu ekatu karanda? Kalabal vela. Ranuja, correct one. Isira, correct. Rusira, yeah, that's the correct answer. Well done. Pramod, there's a slight mistake, Puta. Just go through it again. Then ekatu karana එක තමයි කට්ටිය වරද්ද ගන්න. ලේසිම වැඩේනේ. Gavindu, only the octal number get correct. Binary conversion එකෙත් අවුලක් තියෙනවා, hexa එකෙත් අවුලක් තියෙනවා. Binadi, that's correct. Anjana, oh, there's a slight mistake. Go through it again. Dilni, that is correct. Litira, you have to be very careful when you are adding things. Banapute mistake එකක් වෙලා තියෙනවා. කලබල නැතුව add කරන්න. Anjana, that's correct. All right, if you are done with all three, you can leave, right? Others, you have to send me the answer and leave, right? And people, thank you very much for the people who are leaving. Ranima, yes, that's the correct answer. Well done. Dilmi, yes, that is correct. And that is correct as well as the octal number into the decimal, as well as the third one is also correct. Well done. You can leave Dua. Methula, yes, first one is correct. Yes, Dilni, thank you very much. Good night. And the other one, good night. Rosira, good night. Chamat, yeah, that is correct. That is correct. Methul, there is a problem. Go through again. Binadi, thank you very much, Dua. Metumli, yes, that is the correct answer for the octal. Gavindu, good night. First one is correct, Anusha, as well as the second one. Dilmi, okay. Right, Dilmi, good night. Litira, that's the correct answer. Well done. You can leave. Anjana, yes, that's the correct answer. You can leave. Good night. Anuhas, that's correct. You can leave also. Tisat, yeah, first one is okay. Anjana, good night. Okay, Litira, good night as well. Tisat, second take a pottakai go through Karanabuta. There is a problem. Vatila, Yep. First one is correct. Second and third is not. You have to go through that again, Buddha. Pramod, third one still got some problem, Buddha. You have to go. Vineth, that's correct. The second answer is correct. Pramod, go through Karana Isarayak. Right, Ranima. Good night. Thank you very much. Tisat, yes, that's the correct answer for the second. And Malisha, all your answers are correct. Malisha, all your answers are correct. Well done. You can leave, Buddha. Ranuja, yes, that's the correct answer for the second one. Hasit, the first and second is correct. Third, you got a mistake. Try to do it again. කලබල නැතුව addition එක කරන්න, then you will be okay. Tisat, yeah, that is the correct answer, Buddha. You can leave. Okay, Tisat, thank you very much. Good night. Vineth, brilliant. That's the correct answer. You can leave, Buddha. Well done. Pramod. Yes, yes. C is 13, D is 14, Buddha. Yes. Pramod. 10, 11, 12, A, B, C. C is 12, Buddha. D is 13. Metumli, that's correct. You can leave Dua. Dihan, Puta, the hexadecimal conversion is correct, but not the octal. Podi mistake go through that. Ranuja, yeah, that's the correct conversion. Well done. You can leave. Risara, there is a mistake. It's huge. I mean, like, just go through it. Hasita, that's the correct one. Yes, Metumli. Good night, Dua. Hasita, that's correct. You can leave as well. Well done. Pramod, yes, that's the correct answer, Buddha. You can leave. Good night. Hasita, good night. Thank you very much. Dihan, yeah, well done. That's the correct answers. You can leave, Buddha. Good night. Okay, Pramod. Yes, yes, you stay safe too. Right. Thank you very much.